For as long as human beings have walked this planet, there's been ice in the Arctic.
The climate system itself is driven by ice.
But now, this region is warming twice as fast as the rest of the globe.
You want it to freeze end of October, first part of November, but it hasn't been freezing then.
The whole planet has a fever, but the Arctic's fever is worse.
The Arctic is sort of the home of thresholds, the home of tipping points.
I'm Amy Martin, producer of the podcast and public radio show Threshold. Our team wanted to get a better understanding of what's happening in the North, so we went on a circumpolar journey to find out what the Arctic is, how it's changing, and why that matters to all of us.
We're talking about climate erosion, eroding away the land. It happens to people's cultures too.
In honor of Earth Day, we've put together some highlights from our 13-episode Arctic series, which we're going to share with you right after this news. Hey podcast listeners, what you're hearing here is actually a special episode designed for public radio. This little spot right here is where the NPR newscast would go, followed by about an hour of highlights from Season 2. So if you've already listened to Season 2, there's no new material here, but you might enjoy hearing it repackaged in this format. And we wanted to share it with you because we need your help with something. We really want some public radio stations to put this special on the air. We want to attract more listeners, of course, and we also think Earth Day is a really good time to be bringing more attention to the Arctic. As you know now, the health of the Arctic is crucial to the health of our planet overall. It's also beautiful and fascinating, and it's home to 4 million people who have a lot to teach the rest of us about climate change. So if you'd like to help us get this Earth Day special heard, we're asking you to reach out to your local public radio station and just tell them that you recommend it. You could email them, call them, comment on their Facebook page, tweet at them, whatever works for you. Just a short, friendly heads up that you'd like to hear this show on the radio. Not every station will pick it up, of course, but a few might, and that's more people thinking about the Arctic. More people who are engaging with these incredibly important, overlooked stories playing out in the far north. We have everything that a public radio station would need to air this already set up. They can find us on the Public Radio Exchange, PRX, but you don't even need to know all that. Just reach out to them, tell them you like the show. All the details are at our website, thresholdpodcast.org. We really appreciate your help in getting these stories out to a wider audience. And we're also so grateful to all of you who have donated to help us keep Threshold going. Thanks as well to our major underwriter for Season 2, the Pulitzer Center on Crisis Reporting. We also received crucial support from the Park Foundation and our home public radio station, Montana Public Radio. And for this episode, we have a new sponsor, Change Finance. Is the climate crisis stressing you out? Well, you could just scream into a pillow, or you could drive sustainable corporate behavior through your investments. Change Finance helps you get your investments aligned with your values without sacrificing return. To learn more about their fossil fuel-free investment funds, visit changefinance.net/threshold. Change Finance is a registered investment advisor. This is not an offer to buy or sell any product. Okay, hope you enjoy these highlights, everyone. Happy early Earth Day.
This special episode of Threshold was underwritten by the Pulitzer Center on Crisis Reporting.
I'm on the tiny island of Grímsey, off the northern coast of Iceland, standing in front of a huge concrete ball. It's 9 feet in diameter, and it has a gray, pockmarked, sort of lunar-looking surface. It's super strange. Welcome to this special Earth Day episode of Threshold. I'm Amy Martin, and this thing I'm looking at is called Orbis et Globus. That's Latin for circle and sphere. It's wonderfully weird. Just a huge gray ball sitting in the grass. It feels like I might have found a stone flung from the slingshot of a mythological Nordic giant. But it's actually been placed here very intentionally to mark the place where the Arctic Circle passes through this small island. I can't wait to talk to the artist about it. I love it that it's got this hole through it so you can see through it. I stepped up to look through the hole running through the middle of the ball, and I started to hear something, a low, droning sort of hum.
Oh my gosh, that's what it sounds like?
Arctic Circle. My voice sounds really strange right now because I am talking into an enormous ball of concrete. This is the sound of the Arctic Circle. On a windy spring night at the end of Grímsey Island, this lonely piece of art was singing to itself. Over the next hour, we're going to travel to an Alaskan village and the Greenland ice sheet to learn about climate change in the Arctic. But we're going to start with a really basic question. What is the Arctic? Where exactly does it start and stop? That's where this giant singing ball of concrete comes in. It was designed to mark the place where the Arctic officially begins. This line we've drawn around the top of the world called the Arctic Circle. But there's a plot twist here. Although we're used to seeing this line on our maps and globes as a fixed, permanent thing, this sculpture was designed to move. Why is there a giant ball of concrete on the Arctic Circle? And why does this huge sculpture have to be moved every year in order to stay on the Arctic Circle? The first step in answering that question is understanding that on the summer solstice in June, the sun never sets in the Arctic. And on the winter solstice in December, the sun doesn't come up at all. This is why the Arctic Circle is where it is. It marks this spot where there's 24 hours of light for at least one day each summer and 24 hours of darkness for at least one day each winter. All across the Arctic, people have put up signs on this line, little places for tourists to stop and get their pictures taken. Sometimes locals set up shops nearby and sell souvenirs. And that's the way it's always been on Grímsey Island, too, at least until these two guys got involved.
I'm Steve Kreister, and I'm an architect.
And I'm Kristinn Hrafnsson, and I'm an artist.
How do you say your last name again?
Hrafnsson. Easy. Easy.
I met with Kristinn and Steve in Reykjavik, Iceland's capital, where they've collaborated on lots of public art projects over the years. In 2013, they heard about a competition to make a piece marking the Arctic Circle on the island of Grímsey. And as Kristinn studied the submission guidelines, he got really intrigued by one small detail about the project.
I stumbled across a small number. They said that the Arctic Circle is moving 14 centimeters a year, and I found this rather strange. So I thought, let's search this out.
Kristinn's research led him to the third character in this story.
My name is Thorsteinn Sæmundsson.
Thorsteinn is an astronomer. He's retired now, but he used to work at the University of Iceland.
Actually, my specialty is the effect of the sun on the Earth.
Thorsteinn told them it was true. The Arctic Circle isn't fixed. It moves. And it moves because the angle of the Earth's axis moves. To understand this, it really helps to have a visual aid. So hold your hand up in front of your face, straight up and down, so you're looking at the edge of your first finger. Now, tip your hand forward just a little bit. That's what the Earth's axis looks like. The top of your fingers are in the Arctic, your wrist is in the Antarctic. But now, move your hand back up, just a touch, so it's closer to straight up and down. Then push it forward again. That's what the Earth is doing. That's what we're all doing, riding on this planetary seesaw up and down between 22 and 24.5 degrees. And this movement changes the amount of the planet that goes into total darkness on the winter solstice and total daylight on the summer solstice. Thorsteinn says this movement of the Earth's axis happens in a predictable, cyclical way.
This period is about 40,000 years. 20,000 years in one direction, 20,000 years back.
We're currently somewhere in the middle of that spectrum, kind of splitting the difference between the most tilted and the least tilted spots. But the axis is moving closer to straight up and down, so the Arctic Circle is moving north. And what this means for Iceland is that the circle is slowly slipping away from them. It used to run right through the mainland, but now this small island off the northern coast is the only habitable spot in the country touched by the Arctic Circle. And that's drawn tourists here for decades, as Steve Kreister describes.
As you will have noticed when you arrived in the plane, is there is this sign there made of aluminium, and that's where they unload the tourists off the airplane. They can walk them around the sign, give them a certificate and send them back home again.
In 2013, the local government decided this Arctic Circle marker was due for an upgrade, so they launched a competition, and like Kristen said earlier, the information they put out said that the Arctic Circle was moving 14 centimeters a year. But Thorstein figured out it was actually moving a lot more than that, an average of 14 meters a year. That's the difference between 5.5 inches versus 46 feet. And at that rate, the Arctic Circle will only pass through the island of Grímsey for a few more decades.
It's heading north, yeah. It will leave the island in 2047, I think you calculated. And, yeah.
After that, the Arctic Circle will continue its northern migration for thousands of years, leaving all of Iceland behind until the Earth's axis begins to tilt back in the other direction. This was not great news for the people of Grímsey. They'd always been told the Arctic Circle ran through the middle of their island, right next to the airport and the souvenir shop.
But when we found this out, then we saw this is not true.
Steve and Kristen realized they had a decision to make. They could ignore the science of how the Arctic Circle actually works and just make another stationary monument in the same place where it had always been, or they could take in this new information and let it reshape their whole idea of what this monument was about. As you've no doubt already guessed, they decided the complicated facts were much more interesting than the nice, easy fiction.
So everything is changing. Everything is on the move. So it's a fantastic way of seeing this.
They started to dream up ideas for a moving monument.
We were thinking at one time that we could have a band across the island, and we could get a horse to graze across the line. So we had lots of different ways of representing this moment. And then gradually it crystallized into something as simple as a ball, because it's something you can move. And it also represents what we're on, because everything that we're talking about or thinking about is actually affected by balls. So it seems quite logical that the thing that is being affected at the end of the day is another sphere.
Okay, so some kind of ball, something that can be rolled, but also something that doesn't move too much. Grímsey is a very windy place.
It has to have a certain presence, a certain physicality, a certain weight.
So what did they end up with? An enormous ball of concrete.
The thing weighs 8 tons.
It's 3 meters in diameter, or about 9 feet.
So it's bigger than us. Yeah, there was the thing that we realized that it had to be big enough to be something that you couldn't put your arms around. You know, even if 5 people linked their arms, they'd be having a struggle. So it's something you can't contain. It has its own life and does its own thing, and we just have to follow. And like now, even though we know it's going north, this summer it will go south.
Yep, you heard that right. The Arctic Circle isn't only moving in one direction.
The moon has an effect too.
Thorstein says that as the Earth's axis moves slowly back and forth on that 40,000-year seesaw pattern, there's a much smaller, faster, miniature seesaw happening as well. This wobble is caused by the moon.
And this is called nutation, and it is a period of about 18.6 years.
That's nutation with an N, in case you want to look it up. And what it comes down to is this. Although the Arctic Circle is currently moving northward, that movement isn't a straight line. It's a squiggle, a big line moving in one direction with a bunch of smaller little zigzags contained within it. We've got pictures of it on our website, which definitely helped me wrap my mind around this. And then, just when I thought I really understood what was going on, Thorstein said this.
I must add that there's one factor that comes into this, and people never think about that, or seldom think about that, and that is the movement of the Earth's crust. This is something we cannot predict very accurately.
The Earth's crust itself is moving. The surface of the planet. It's made of moving parts. Every spot that we're standing on was once in a different place, and will be in a different place again later. I have to say, as I was learning all of this, my heart kind of went out to Steve and Kristen and the organizers of this competition. It seemed like a simple challenge. Make a monument to the Arctic Circle. You know, just something pretty or interesting to place on this tidy little line that human beings have drawn around the top of the Earth. But the deeper these two went into that project, the more complexity was revealed.
But I think that's also something you accept as you get older. You realize that you don't have a grasp on everything. The older you get, the more you realize you don't know.
This kind of thing has happened to all of us. This moment when we find out some new information that makes everything so much harder and more complicated than we thought it was. And then we have to decide if we're going to take that in or turn away. This happens with climate change. As we learn about how our human activities are impacting the climate, it can get so overwhelming that we'll twist ourselves into knots in the effort to avoid accepting reality. And one of those knots is related to this movement of the Earth's axis, that seesaw thing that we did with our hands before. Some people are spreading the idea that this change in axial tilt is one of several natural processes that are heating up the planet, not our human actions. You may have heard this yourself and wondered, could there be anything to that? So let's just examine it quickly. First of all, the Earth's climate does, of course, change naturally. Historically, the planet has fluctuated between ice ages and warmer periods, and changes in axial tilt are part of what drives that pattern. But those changes play out over huge timescales, tens or even hundreds of thousands of years. The warming we're experiencing now is happening at lightning speed in comparison. It can be measured in decades and centuries. And the cause of that warming is not a mystery. It's us. And this is a total drag. Like, it'd be so much easier if this wasn't true and we could blame global warming on the stars or the aliens or anything other than ourselves. But the reality is, burning fossil fuels moves carbon into the atmosphere, and that heats up the planet. This is not in doubt. It's a fact. So we have a choice. Do we accept the truth, as difficult as it might be, or do we try to push it aside so that we don't have to change? When it came to making this Arctic Circle monument, Steve and Kristen chose option number 1. They opened themselves up to wherever the more complicated truth might lead. And it turned out to lead to something pretty darn cool.
This is a moving thing. It follows the circle, which is nothing you can touch or see. And that's interesting, that the object is following this idea.
The ball is the least important thing about it. The piece itself is the movement.
We humans don't really like change. We like to make sharp lines and firm definitions, and once we get comfortable, we want to stay that way. But the actual physical world doesn't really work this way. It's really hard to find a straight line in nature. Instead, there are curves and twists, blurred boundaries and overlapping branches, and always change.
Everything moves. Everything. Nothing excluded.
Even the Arctic Circle, and an 8-ton ball of concrete, both of which are scheduled to leave Grímsey Island in the year 2047.
And that's when Kristen and I go up there with our Zimmer frames and kick it into the ocean.
What is a Zimmer frame?
It's a walker, a grind.
Okay, gotcha. So the question we started with here is, what is the Arctic? The answer? Anything above a zigzaggy line, which fluctuates between 65.5 and 68 degrees north, which is so messy and complicated. There's really nothing about the Arctic that obeys our rules.
We are very small in this universe. Much, much smaller and less significant than most people think.
We'll have more stories from the Arctic right after this short break.
To hear all 13 of our episodes from the Arctic, subscribe to Threshold on iTunes or wherever you get your podcasts. You can also listen at our website, thresholdpodcast.org. This special episode of Threshold is sponsored by listeners like you and by Change Finance. If the climate crisis is stressing you out, you could just scream into a pillow, or you could drive sustainable corporate behavior through your investments. Change Finance helps you get your investments aligned with your values without sacrificing return. To learn more about their fossil fuel-free investment funds, visit change-finance.net/threshold. Change Finance is a registered investment advisor. This is not an offer to buy or sell any product.
Welcome back to this special Earth Day episode of Threshold. I'm Amy Martin, and we're bringing you highlights from our 18 months of Arctic reporting. We're going to leave Iceland behind now and head over to Northwest Alaska. It's a summer night, and the kids of Shishmaref, Alaska are on the loose.
How are you, Walter? Good. How's your day?
My day is good. How's your day, sir?
Good.
What are you guys playing?
We're just playing around.
Just playing around.
This is Walter Nyakpuk. He's 10 years old.
What's wrong?
Right here on my ribs hurts. I ran too much.
He takes a break from this swirling, giggling kid mosh pit to catch his breath and ponder the universal rituals of childhood.
Girls are supposed to be chasing us.
Why are the girls supposed to be chasing the boys?
Because they like them.
Shishmaref is a small town on a barrier island in northwest Alaska, just shy of the Arctic Circle. About 600 people live here. There's a church, a school, 2 stores, and around 150 houses connected by a couple of paved roads and footpaths through the sand. This island is tiny, and kids here are pretty free to roam. Tonight, everyone under the age of 15 seems to have spontaneously gathered here, in a wide spot between some houses, to chase each other around in the sand.
What's your favorite thing about living in Shishmaref?
It's fun.
Why is it fun?
Because there's a lot of kids.
There are a lot of kids. There's so many kids.
And we can be free.
And you can be free. Yeah.
From Walter's point of view, Shishmaref is a kind of paradise, a whole island of free-range, kid-friendly habitat. But the paradox of Shishmaref is that it might be both one of the safest and one of the most dangerous places to live in America today, because this small community is one of the places where climate change is hitting the hardest in the Arctic. Shishmaref is located just north of the Bering Strait. That's the narrow waterway that separates Russia from Alaska. It's the only town on Shishmaref Island, and everywhere you go, you can see the waves and hear the constant roar of the ocean. This island is only about a quarter mile wide. That's 440 yards, or less than half a kilometer, and it's getting smaller.
It's changed a lot. It was always frozen like the end of October. It no longer is.
This is Kate Kokyok. She grew up here, and now she teaches kindergarten at the Shishmaref school. And she says the sea ice used to serve as a buffer for this little island. It would freeze up in the fall before Arctic storms blew in, which meant that the wind and waves battered the edge of the ice instead of the edge of the island. But now, as the climate warms, sea ice is forming later and later, and waves that used to break far away from the coastline slam directly into Shishmaref Island.
Like, you look outside and you want it to freeze end of October, first part of November, because that's when we start to have our storms. But it hasn't been freezing then.
At the same time, the frozen soil, or permafrost, that the town is built on has been thawing. And the combined effect is that the ocean is essentially eating Shishmaref, mostly in small, relentless nibbles, but every so often a major storm blows in, and the waves take big, deadly bites out of the coastline. Between 2003 and 2014, Shishmaref Island lost an average of 2.3 meters annually. That's 7.5 feet of land washing into the sea each year.
We did lose a lot of land. Like where the seawall is now, that's where we used to have our playground. So all of that is gone. You know, I remember in 97, they were emptying out a house because it was shaking and it was undercutting, so they were worried that it was going to fall over. So during the storm, they were emptying out the house and they lifted it up and moved it a few feet onto the road, you know? So that's the one that I remember.
I've never been in a place like Shishmaref before, where the community's mental map is so different from the current physical map. It's like there's a drowned ghost town ringing the island, full of images and stories.
We had lots of room to play out on the beach, play baseball or tag or whatever. You had beach way out there. You know, we had big sand dunes that we play on there, jump around.
This is Stanley Tocktoo, the vice mayor of Shishmaref.
Tocktoo, T-O-C-K-T-O-O. I was born in Shishmaref, 1961, July 24.
Stanley says decades ago, when he was a kid, the island was twice as wide as it is now.
We go way the hell down there, park our boats on the beach, put tents out there once in a while. Yeah, but now it's submerged under the water, so yeah. This island's only 3 miles by a quarter mile wide. Yeah, maybe a little narrower now. Climate change is real, you know.
The people of Shishmaref have voted to relocate to the mainland, but they need around $180 million to make the move. And they're not alone. At least 30 other communities in coastal Alaska are in similar situations. And so far, they've had a really hard time getting their needs heard in Washington.
I can't believe that our president don't believe in climate change, you know. Look at our lifestyle, look at our erosion problems, you know. We're Americans too, you know, we don't have to be treated like a third world country.
Any one of these monster storms could come spinning in off the Bering Sea and overwash a village.
This is Joel Clement. He's a scientist and policy analyst who used to work at the U.S. Department of the Interior.
I mean, we've got the information that shows that they could be overtopped by 6 feet. They don't have any way to get out of harm's way right now. So they're in a tough spot in the fall with the storm season. That's what I worry about. That's the top level thing I worry about.
Joel was hired in 2010 when Barack Obama was president and Ken Salazar was the department secretary. At that point, the Government Accountability Office had already issued 2 reports that said 31 Alaskan communities, including Shishmaref, were in imminent danger.
I mean, government should be scrambling to try and find ways and dollars to get people out of harm's way and find innovative ways to do that.
People from Shishmaref and other Alaskan communities traveled to D.C. to make the case for funding climate change resilience in the Arctic. But Congress was not supportive. In fact, many elected officials were, and still are, not willing to accept that humans are changing the climate at all.
So finding dollars was very difficult. We did manage to get some grant money and some grant programs spun up, but boy, it just, it's embarrassingly difficult to find those dollars within the federal government.
In December 2016, just before President Obama left office, he signed an executive order establishing a new climate resilience area. Basically, it was a structure for protecting marine resources and coordinating climate change projects in the northern Bering Sea, with tribal leaders at the helm.
And this included a lot of the villages that we're talking about here, and it was a way for them to get a seat at the planning table for the region.
Joel was optimistic that this executive order would finally lead to meaningful action for communities in the Alaskan Arctic. Donald Trump had been elected president in November, and he famously called climate change a hoax, but
frankly, despite all the anti-climate change rhetoric out of these new folks, I wasn't worried about climate change adaptation because you're addressing issues that are very clear in front of you. People are being directly impacted by climate change. It's not a model, it's not a theory, it's fact. And so I wasn't worried. I thought that work would continue. And of course, I was being very naive.
On March 1st, 2017, Ryan Zinke was sworn in as the new Secretary of the Interior. By the end of April, Obama's executive order was revoked, and all the plans for helping these Arctic Alaskan communities were dead in the water.
The Bering Sea tribal elders quickly wrote a letter saying, "What gives? We thought everybody was okay with this." It was a clear shot across the bow that, hey, it doesn't matter whether you're working on reducing greenhouse gas emissions or protecting people in peril, anything that has a whiff of climate change to it has to stop.
But for Joel, it was clear that denying climate change meant ignoring the fact that people were in real danger. So he kept sounding the alarm.
So I was speaking very publicly in Alaska and elsewhere about the work, saying, hey, resilience and adaptation are just as important, if not more important than they ever were. We need to continue to do this work.
And then, a few months later, he received a surprising email.
Reassigning me from my job as director of the policy office to a job in the office that collects and disperses royalty income from oil, gas, and mining companies.
And how did that strike you?
Well, immediately I could tell that this was retaliation for my climate change work and that this was not good news. But when I found out that dozens more senior executives like me had been reassigned, I realized that I was part of a purge. And I started thinking, how on earth do I respond to this? Because this is clearly inappropriate.
Joel has no training in accounting. He says it was obvious that he was not qualified for the job he was reassigned to. He was convinced this was an attempt to silence him. So he found a lawyer and filed a whistleblower complaint, which is currently being investigated by the Office of Special Counsel. He also wrote an op-ed in the Washington Post and started speaking publicly whenever possible, trying to shine a light on what's at stake here. And what's at stake are the people of Shishmaref and other Arctic Alaskan communities. This isn't really about his job, he says. It's about a hostility to science at the highest levels of government, which he believes is putting the American people in real danger. What would you say to people who are like, well, it's your problem. Why should the state of Alaska or the federal government or anyone else help you? If you need $200 million to move, go find $200 million and good luck to you.
Yeah, well, they'll be saying the same thing to Miami pretty soon, right? So, I mean, what happens up there in the face of climate change is an important bellwether for what's going to happen in the rest of the coastal areas of the United States, right? Are we going to leave American citizens to their own devices to get themselves out of harm's way? Or do we provide assistance to do that, right? I mean, we are all American citizens and we have some expectation that we're not on our own, right? And that's one of the things that makes this country great. And my gosh, I mean, we're going to be seeing this very same dynamic elsewhere around the country. And as always, the poor, the communities of color, the have-nots are the ones that suffer the most.
I mean, how likely do you think it is that a storm would overtop the island? I mean, have people penciled out the odds like, oh, this is a 10% chance per year or a 40% chance or...
No one has penciled out the odds to my knowledge. I think based on the information that I have and the trends that we're seeing now, I would guess that within 10 years, we're going to lose a village and maybe more. And hopefully that doesn't happen. I hate the thought of it because there's possible risk of loss of life.
We first reported this story before Ryan Zinke resigned as Secretary of the Interior, and we reached out to him for comment. He didn't respond.
I've heard something to the effect of these dumb Eskimos. Why did they build a community on a barrier island? The fact of the matter is because the church and the Bureau of Indian Affairs school was built. So I think that's a major misconception.
Kelly Enningwalk grew up in Shishmaref, but she lives in Anchorage now. She's the executive director of the Inuit Circumpolar Council in Alaska, an organization that works to promote and protect indigenous rights in the Arctic. And she says a lot of people don't understand how this community ended up in its current predicament. To begin with, she says, you have to know that one of the best survival tools for people here has always been movement, seasonal migration. So Kelly's ancestors used Shishmaref Island, where Shishmaref is located now, but they didn't live there year-round.
And that's the thing, they were kind of semi-nomadic. We didn't have permanent settlements and that sort of thing.
But in the early 1900s, that began to change. The Lutheran Church and the Bureau of Indian Affairs arrived and told people that a church and a school and the ideologies contained within them were moving in to stay. The only question was where to put the buildings. So why is Shishmaref located where it is?
It was because the school was built and a church was built. And so the community established and became a permanent village in that way.
Most people in Shishmaref identify as Inupiaq. That's a subgroup of the Inuit. And they've been living in this part of the world for a really long time, honing the best methods for finding food, making clothing and shelter, and building healthy families and communities in this very harsh environment. Kelly says one of the most painful aspects of colonization is the way it taught people to devalue their expertise and the whole worldview behind it. She grew up with her grandparents and considers her grandfather one of her primary teachers, but
he said himself he was dumb because he only went to junior high. He didn't go to high school. And I mean, gosh, that really kind of hurt inside for me to hear him say that, and kind of blew me away. Like, he should have had a PhD in everything about life, So it kind of also gave me some insight into kind of, the impact, the colonialization and assimilation that had on his generation, and how it brought shame and just a level of insecurity, I think, like in themselves. And the pride in being Inupiaq was lesser, or I don't know how to explain it. Like it was that generation that really got hit hard. They're the ones that were hit with, for speaking Inupiaq. So
truly hit hard.
Yeah.
So imagine that your hometown just suddenly washes away all the grave sites, your childhood house, your school, and everybody that you know has to move somewhere else.
Krista Sanook teaches 3rd grade here in Shishmaref.
And that threat's really real, and even the little kids are aware of it.
If you ask people here if the Arctic is warming, they look at you like, duh. It's a weird question, kind of like standing on the deck of the Titanic, arguing about whether or not there really is a hole in the ship. That debate is utterly detached from the reality of people's lives, and it wastes time, when time is of the essence.
If you were watching somebody drowning in the ocean, would you just boat by and say, oh, somebody else will save them? You wouldn't do that, so why are you doing it right now with all of these places?
Krista moved to Shishmaref in 2012, and she says sometimes her friends from home ask her, why don't people there just move to some other town, like Nome or Fairbanks or Seattle? Why are they insisting on relocating the whole village? But Krista says that in Shishmaref, that's basically like telling the community to let their culture go extinct. It's something she had to learn as a white person who grew up in the lower 48.
It would be like saying, oh, sure, just abandon America and go to Argentina. That would be great, right? And you would be like, it kind of looks the same and it really doesn't feel the same. And you would lose very quickly what makes your culture yours. It would be very easily absorbed into something else. And it's really easy for some people to forget because our culture is prominent. Like, my culture is everywhere in America, so it's easy for me to forget that it could be taken apart. And this is a very small, specific culture. Inupiaq to Shishmaref is only existing here. Inupiaq is big, but Shishmaref Inupiaq is only existing right here. And if we take it out of Shishmaref, it has the ability to just break apart. I mean, we're talking about climate erosion, eroding away the land. It happens to people's cultures too.
We're going to lose our island. We got no place to go. There's no road to go to the mainland over here,
Vice Mayor Stanley talked to knows as well as anyone just how bad things could get when that next big storm hits. And he could move out of Shishmaref, get a job in another town, and just leave all of this behind. But he doesn't want to do that. He points out the window to the kids playing outside.
We're not trying to make a new home for myself. We're trying to build these things for them so they could have a home and do the certain lifestyle we have,
I went to church services when I was in Shishmaref, and the choir sang this song called Invisible Hands. The lyrics go, invisible hands will keep you from danger. Invisible hands will keep you from harm. The gospel reading that day was Matthew 14, the story of Jesus walking on the water. But here, where the cold Arctic waves are circling this village in an ever tighter noose, people aren't asking for miracles. They're just trying to do what they've always done: stick together.
If you want to hear more voices from Shishmaref and other Arctic communities, subscribe to Threshold wherever you get your podcasts. And you can find pictures and videos from our polar journey at thresholdpodcast.org. Coming up, we'll take you to the Greenland ice sheet. Stay with us.
Welcome back to this special Earth Day episode of Threshold, featuring highlights from our circumpolar journey to all 8 Arctic countries. I'm Amy Martin, and I'm sitting in a helicopter with 3 students and 3 professors staring out the window at the Greenland ice sheet. Everything about this ice sheet is fascinating to me. Even though it looks flat, at its highest point, it's more than 10,000 feet tall, taller than many mountains. In fact, that's kind of what the Greenland ice sheet is, an upside-down mountain of ice. But there's no mountain this big on Earth. This thing is the same size as the state of Alaska, and it has snowflakes locked in its belly that fell from the sky more than 100,000 years ago. The helicopter touches down and the pilot opens the door, welcoming us to our home for the next 5 days.
Should I go ahead and hop out?
Yeah, go ahead.
As soon as we climb out, we're battered by gale force winds. We unload quickly and the helicopter takes off, leaving our little crew of 7 huddled together around our gear. We are the only splotch of color out here. It's ice as far as we can see in all directions.
So here's the plan. We're going to set up our personal tents. Everybody gets a tent, a piece of white foam, and then this big taco pad that goes down.
This is Joel Harper, a glaciologist from the University of Montana, and the person I had somehow convinced to let me come along on this scientific expedition. It's a clear day, but storms can roll in at any time, so setting up shelter is a priority.
The key to setting up your personal tent is do not let the tent blow away, or you will be never seeing it again, and cold for a while.
This massive piece of ice is so important for so many reasons. It holds precious information about the distant past, and it's a big part of our climate future. That's why this team of scientists has been coming here for years.
It's such an amazing looking surface. Like, it's not anything like a snowy field.
No.
It's also not like an ice rink or something. It's totally unique.
It's a pretty interesting surface with this honeycomb. I mean, half of what we're walking around on is not ice. It's whole, filled with water.
Yeah, and I was just thinking when I was when I went off to pee, I felt sort of bad because I'm peeing on fresh water. Wherever you step, wherever you pee, anything you do, you're just soiling fresh water. And it really struck me of this is such an amazing resource of fresh water when there's so many places that need fresh water.
Yeah, there's a lot of it here. If you took all this ice and converted it to water and added it to the ocean, sea level would come up 7 meters. Whoa. So that's how much ice is here. Quite a lot.
Wow. 7 meters is about 23 feet. Adding that much water to the ocean would displace millions of people, from Louisiana to Bangladesh to the UK. The good news is, Joel says we're not going to lose the whole ice sheet all at once. But the bad news is...
even if we get 2 meters, that's a big amount of water. That's a lot of sea level rise that the coastal places have to deal with. The question is, how much do we get in 100 years or 200 years? It's all about the rate. We know what the number is. It's 7 meters. How fast can we move that into the ocean?
That's what Joel Harper and this team of scientists are trying to figure out. How fast and through what combination of processes will this mountain of ice end up in the sea? It's an area of study called ice sheet dynamics, and the first step in understanding it is grasping that this ice is dynamic. It moves. Like all fluids, it flows from high to low. The ice sheet is fattest in the middle and then tapers out to the edges.
Well, the thickest part of the ice sheet's about 3,200 meters thick.
But we are camped over ice that's only about 700 meters thick. That's the difference between 10,000 feet and a little more than 2,000 feet, a significant elevation change.
Ice sheet motion is taking mass from the high parts of the ice sheet where it's relatively sequestered from contributing to the ocean. It's cold. It's a long way from the ocean. Ice sheet motion takes that ice and moves the mass towards low elevation where it either melts in warmer temperatures or calves off into the ocean.
The movement of the ice from high to low and the calving off of the ice into the ocean, that's normal. If you see a picture of a big chunk of ice falling into the sea, that is not in and of itself an image of climate catastrophe. That's what this ice sheet does. It moves, it melts on the edges, it breaks off into the ocean. But, and this is a big but, at the same time that it loses mass on the periphery, it gains it in the middle, or at least it has been.
Problem is we're having more mass loss than we are gain at the moment, so that's why sea level's going up. The mass of the ice sheet's going down.
As we warm the planet, we're knocking the balance out of whack here. We're losing more ice than we're gaining, and the ice sheet is getting smaller. And as it's become clear that the ice sheet is no longer a permanent fixture on the landscape, the question of how it moves and how quickly it can move has started to become incredibly important.
So that's where all of our uncertainty comes from in projecting the future of sea level rise from Greenland, is how fast can this thing move? How fast can this thing take mass from the central high elevation places and deliver that mass to the edges where it can be put into the oceans? That's why what we're doing really matters.
So, how long before all of this ice ends up in the ocean?
I think the community's fairly well reached consensus that it's not a decade, it's not really even a century thing, that we can get all of it. I mean, it's 7 meters here. The question is, how much do we get in 100 years or 200 years?
So we're not going to just wake up one morning and discover that the whole ice sheet is gone. But we don't really know how long it would take to lose the whole thing. That depends on a lot of things this team is studying. There are all kinds of interrelated mysteries to solve. Is it more likely to melt at a steady pace or in pulses? What role does surface melt play? What happens if the ice sheet begins to break apart? Could a smaller section of it suddenly start moving faster and throw previous calculations off?
This is where the motion part that we're working on really comes to play.
Understanding all of this stuff matters because the speed of sea level rise has everything to do with how well people and animals and plants can adapt to it. And Joel says the potential sea level rise is actually only one of the reasons why this ice sheet is so important.
Ice itself is a big part of the climate system. Ice actually influences how the climate system works.
One of the ways it does that is through albedo, the reflective power of the ice. The Greenland ice sheet acts like a powerful mirror, bouncing solar energy away from the Earth back out into space.
The Earth has constant heat coming in from the sun and heat going back out. But at the equator, way more heat comes in than goes out. So that heat moves through the oceans, through the atmosphere, to the poles, where way more heat goes out than comes in. So here's where we lose our heat. It's our pit zips.
I love it, yes.
This cracked me up because it's something only a glaciologist or a serious skier would say, and Joel is both. You find pit zips in a lot of winter sports jackets these days, zippers that allow you to open up the armpits and release some body heat. They basically help you keep your own personal mini climate in the Goldilocks zone, not too hot, not too cold. And what Joel's saying is that the frozen polar regions provide that same service for the planet. They vent heat out of the Earth's climate system, helping to keep it in that just right range. But as we've been adding heat-trapping gases to the atmosphere, these polar pit zips can't keep up.
If we're piling in a lot more heat around the planet, it's inevitably finding its way to the poles, and this is where we're starting to get a lot of extra warming going on up here because it's accumulating here. The heat is traveling to the pit zip and it can't get out.
And when the Earth's heat piles up at the pit zips, all kinds of things start to get weird. Weather, storms, ocean currents, the jet stream. That's why there's some urgency here to get a better understanding of the processes that are transforming this big hunk of planet-cooling ice into water. And Joel says there are a lot of unanswered questions.
Yeah, we have a lot to learn about how glaciers and ice sheets move, the mechanics of motion.
When we were flying into camp, I was struck by how textured the surface of the ice sheet is. It's not just a big blank slab. It has bumps and cracks and serpentine blue rivers running across it. And Joel says there are also rivers and lakes inside the ice sheet and underneath it. It has an internal architecture, or maybe a plumbing system is a better analogy. In fact, Joel had given us a pretty stern safety talk, warning us about these things called moulins, holes you can fall into on the ice sheet, never to be seen again. He says we don't really know all that much yet about how all of that internal plumbing might affect the overall movement of the ice sheet. Joel is leading us on a hike out away from camp to meet a moulin. We follow a stream across the ice sheet, and then there it is.
Wow.
A big hole where the water is just cascading in and disappearing.
So it's safe here, but you don't want to step out there.
Yeah, don't worry.
But you can see the stream is just plunging into the glacier.
And it's plenty deep for a person to get through that.
Yeah, you would have no problem. And not only do you not want to fall in that hole, you don't want to fall in this stream anywhere because the bottom of that stream is just ice. It's completely slippery. You're just getting slid along this wet, slippery slide, and it's really hard to get yourself out.
Oh, God.
And the current just carries you along until you end up in the hole.
Oy.
Moulins are pretty spooky, but they're also beautiful. The rushing water reveals these layers of deepening blue descending into the ice sheet. And for scientists, these things are very intriguing portals into the belly of this icy beast.
20 years ago, there was some debate as to whether or not water could find its way to the bed of the ice sheet, this surface melt we see, whether it could even get through a kilometer of really cold ice. Since then, we've learned that it absolutely does. But now we're stuck with two new problems. One is how. We don't have that figured out entirely. And the second is, well, what are the impacts of that? What does it do to the sliding motion of the ice sheet?
Once it gets down there.
Once it gets down there.
There's a spot a little ways off where it's safe enough for me to lie down and put the microphone right into the mouth of the ice sheet and listen to its voice. Seeing and hearing all this water move around up here really brings home that this is a massive source of future sea level rise. 600 million people live in coastal areas less than 32 feet above sea level. And as we warm the planet and the Greenland ice sheet melts away, a lot of those people are going to have to find somewhere else to live. That's a recipe for intense societal disruption, hunger, disease, conflict. That's why we need to figure out how this giant ice cube moves as the world warms up.
What really matters here is how fast. You know, if it takes 3 or 4 millennia to get a large amount of melt from Greenland into the ocean, that's a completely different societal issue if it's only a century or 2 or 3.
The term ice sheet dynamics sounds really abstract, but the work this team is doing intersects with questions that have huge moral implications for people and ecosystems around the globe.
The climate system itself is driven by ice. Even if you live at a southern latitude somewhere, if there's big change in the poles, it will impact how the climate system works, and it will ultimately work its way down to impacting you.
more I learned about the Arctic, the more I realized that it is doing stuff for us. All of us. We're in a relationship with all of the frozen stuff up there. But for the most part, it's been really one-sided. The ice has been helping us by keeping our climate stable, but we've been pretty much ignoring it. It's never occurred to most of us to consider what our lives would be like without a frozen Arctic, because it's never even seemed possible that it could melt. Until now. And we still have a chance to slow the melting of the Arctic, but that window of opportunity won't stay open forever. Thank you for listening to this Threshold Earth Day special. If you subscribe to our podcast, you'll meet more fascinating Arctic scientists, and you'll also meet more people with deep cultural roots in the polar north. Sami reindeer herders in Norway, Inuit rock stars in Canada, and many more of the 4 million people who call this region home. Listen at thresholdpodcast.org or wherever you get your podcasts. Threshold is made by Nick Mott, Cheryl Skibicki, Michelle Woods, Rachel Kramer, and me, Amy Martin. Our music is by Travis Yost. Thank you to our community of supporters, led by the Pulitzer Center on Crisis Reporting, the Park Foundation, and Montana Public Radio.